Hello everyone. Welcome to another segment on the TYS explanation. Today we are doing the 2023 paper, paper 1. So if you're using the physics chem paper, then it will be the number question 1. So let me begin. Titration is carried out to measure the volume of acid um, needed to neutralize aqueous sodium hydroxide. So this is a typical neutralization experiment. Can you remember what is a titration? Yeah, so I draw a simple burette here. Okay, and then you have a conical flask, right? So you either put your acid or your alkaline into these two apparatus. So with this respect to this question, um, 25, so you have 25 centimeter cube of sodium hydroxide, and in the burette you put in acid, right? So acid here is HCl. Okay, so they say exactly 25 aqueous sodium hydroxide is measured out into conical flask, and hydrochloric acid is added. So this is neutralization. So HCl added to sodium hydroxide. So which apparatus is used during this experiment? From what I can see is pipette, right? So pipette is used to measure the sodium hydroxide, and the burette is in the acid is added into the burette. Okay, second question. 4 bottles containing colorless solutions that have no labels. So the keyword, step number 1, list out what is given to you, colorless. Okay, that means there's no copper ions, no iron ions, or any colored ions that you have recall from your QA. Okay, this is a QA question. So they want to know how do you identify ammonium chloride. So for those of you who are not aware, okay, let me see. Okay, so um, ammonium, potassium, sodium, salts or solutions are all colorless. Okay, if you don't know, now you know. Okay, it's no big deal. Okay, all colorless solution. Okay, and you can see that I always use this piece of note. Okay, in case you don't understand, that means potassium chloride, potassium sulfate, potassium nitrate, potassium chloride, potassium carbonate, or ammonium carbonate, all that start with potassium something, sodium something, or ammonium something are all colorless, and they are all soluble. If you notice very carefully, all the salts are soluble and colorless. Okay, go back. So it is a colorless solution, and according to this, you want to know how do you differentiate. Now take a look at it. So chloride, so ammonium, this is how you represent ammonium, and this is how you represent chloride ions. So you have chloride ions and ammonium ions. So look at the QA notes. So if there's aluminium, you see ammonia gas is produced, and you see a dash line over there. Okay, then we go chloride. How do you identify chloride? Chloride. Let me see where's chloride. Okay, this is chloride. You added this, and you should have a white PPT form. Who can remember what is the name of this chloride? Again, it's silver chloride. Okay, for the sake of studying, I always write this down. Okay, you always write this down so that whenever you look at this piece of paper, you know that the white PPT has a name, and PPT is called barium sulfate. Okay, it is a product form. It doesn't mean that the solution contains barium sulfate. Okay, it doesn't mean that this is, it means that this is a product form after you add it in, whatever reagent to your sample. This is a product. This is not the the salts present in it. Okay, so for ammonium, can you see this? Ammonium produced on warming. That means it will turn, a gas is produced that turns red litmus paper blue, right? Because ammonia gas is produced. Can you see this? Nothing there. That means no gas, no PPT, no gas. Okay, whatsoever. Please remember this. So ammonium, if there's ammonium present inside your sample, not only is it colorless, but if you add sodium hydroxide into that solution, the sample that contains ammonium, this gas is produced. So let's go back to the question. So this solution contains ammonium. So definitely, if you add sodium hydroxide, alright, there should be a gas produced which turns red litmus paper blue. So see, it looks like this is wrong. Okay, looks good, looks good, looks good. Okay, then only 3 of them is correct. And then can you see this? So you added nitric acid together with silver nitrate. Okay, if you cannot remember, isn't it this one, right? Is this one, right? So what do you see? White PPT. So that means, okay. This one you don't need to think about it because there are two correct answers. As yes, of course, hydrochloric acid added to ammonium chloride. Basically, there is no no reactions. Okay. So sometimes you don't need to figure out every single options, the clue inside every options. Question number 3, a temperature of a sample of gas is increased. The temperature, okay, so what does that mean? That means originally let's say you have a container of gas, this is 30 degrees Celsius, then you increase it to say 60 degrees Celsius. Okay, doesn't matter what temperature, it simply means that which row describe the changes in both the rate of collision and average speed. I think this is quite straightforward, right? If you increase the temperature, of course the speed of the gas particle increase, getting hotter, they got more kinetic energy, and of course then you get to the reactant particles get to hit again each other more frequently, right? The frequency increases. So this is D. Number 4, the atomic structures of 4 different particles. Now notice how this question works. They say particles, they never say atoms. So that means it can be atoms, it can be positive ions or negative ion. Okay, learn this trick. So okay, so the particle, so the first one is aluminium, second one is called aluminium ion, and then sulfur, and this is sulfite, which is actually a sulfur ion. Okay, look at the charges valency. Okay, so aluminium, okay, uh, is an atom, it's not an ion because there's no charges. If that is the case, that means the number of proton and the electrons are equal. Okay, there's no loss of electrons. So if the original number of proton is 13, that's why electron is 13, and there's no difference, right? So W is either 13. Again, look at sulfur. Sulfur atom is 16 and 16. Yes, that's correct. Okay, now the tricky part is here. The 3 plus means loss 3 valence electron, not gain. A lot of students always make this mistake. If you lost 3 valence electron, then you may ask me, how come it's positive? Now I use mathematics. Because proton is always positive, right? If you lose 3 electrons, that means you lose 3 electrons. How many electrons are there left? Isn't it 10? Remember, for atoms, the number of protons is always equal to the number of electrons. So if you start to lose electron, okay, you started with originally 13 and 13. Okay, now you lose 3 electrons. 3 plus means 3 electrons. Therefore, you're left with 10 electrons. If you're left with 10 electrons, and electrons are negative charge, so what is the overall charge? Isn't it positive 3? Right? So that's why it's okay. We in ions we write 3 positive, we don't write positive 3. But you can see that it's positively 3 charged. Okay, so that's why it's positive 3. So that means this X must be 10. Okay, the other way the same. It's the same. So let's look at sulfur. So if it's an atom, then 16 versus 16. Okay, fine. Now can you see 2 minus there? What does that mean? That means something has happened to the particle and it has gained 2 electrons. So I do the sum again. So 16, right? So positive 16 proton. And then it gained 2, so maybe minus 18, right? That's why it's called negative 2. That's why it's 2 minus, right? So the answer should be this one, right? Okay, and B. So go and revise. When an atom loses electrons, it becomes positive charge. When an atom gains electrons, it is negative charge. They may ask me what type of atoms lose electrons. So it has to be metal elements, and of course the opposite are non-metals. However, not all non-metals lose electron, right? Because some of them would rather share the valence electron to form a bond. We come to it when we see such a question. Okay, number 5, gallium. Gallium combines with sulfur to make an ionic compound called gallium sulfide. Okay, you may look at your periodic table and you try to find gallium. Gallium is in group 13, period 1, 2, 3, 4, period 4. Okay, so you are only required to know how to draw electronic structure for calcium. So you do not need to know how to draw the atomic structure of gallium. Okay, only until calcium. Okay, so never mind. The gallium, it belongs to group 13. 13, right? So how does it fit into this question? Okay, let's look at step 1 is we look at what information we have, right? Then we deduce what hidden information or what other further information we can get from there. Okay, it's always like that. Step 1, look at all the information you have. Don't look at one statement, look at all the information. So, I saw this formula. Ga2S3. Now, if those are students who are good in formula, you will know that to get this formula, the gallium must have 3 positive, sulfur 2 minus. Right? If you look at the periodic table, because it's group 13, so obviously it will be positive 3. Group 1 will form positive 1, group 2 will form positive 2 ions, and group 13 metallic elements will form positive 3 ions. So up to you. There are 2 ways to derive. Okay, so if you are still perturbed on how I got this, okay, so imagine you know these 2 and you write down the formula, and isn't this the same as the formula? So this question is asking you, do you know how to derive formula? Okay, by looking at the formula, can you go back, go back? Okay, I'll give you another example. So if you have MgCl2, can you work backward to find out what are the charges? So you work backward, you put the 2 on top. If you work backward, you have Mg2 plus and Cl minus. Am I right? Yeah, so this is the formula, and these are the ions. Please do not mistaken formula with ions. Formulas do not have any charges, right? So you cannot see any charges over here. Let's see when I can erase. I can't erase. Okay, never mind. Okay, so so the ions present should looks like this one, this one, this one, and this one, right? Oh, I saw the melting point. Because it's an ionic compound, they should have high melting point. So answer is B. Number 6, oh, straightforward. What is the MR? So look at your periodic table. Look at the relative atomic mass for nitrogen, which is the bottom number. The bottom number. Right, so the bottom number, not the top number. Please don't get it wrong. Relative atomic mass is the bottom number. There you can see it over here. The top number is the proton number. Do not mix them up. So proton number simply means number of protons. It's for drawing electronic structures. Okay. So I do it quickly. So 14 plus 4, because 1 times 4 hydrogen, right? Then multiply by 2. Then you add the next element, which is 12 plus 16 times 3. Okay, so what do you have? If you press your calculator, I think the answer should be 96. Okay. Question 7. This is a typical calculation question. Again, is the neutralization, right? Can you see the acid and can you see the base? In this case, it's alkaline. Acid plus base, salt and water. And I saw this phrase here. Can you see that? Okay, a bit of calculation. Again, I have to emphasize this. In calculations, you are always given the data of one of the chemical, and then you have to find the answer to the other chemical. It's not about the same chemical. So let me do it. So whenever you see such a thing, right, this is sodium hydroxide, and you need to find out something about this, right? In this case, the concentration. Right? Do not go about and start to think complicated. It's not complicated. So you just take a look. I'm given sodium hydroxide, and you need to find something about sulfuric acid. So okay, take a look at this one. Oh, I saw this. I always tell us, if you see this, you take 0.5 multiply by the volume. So the volume is 28, which is by 2000, 1000. And if you do that, you get answer called 0.014. Now what is that value? This is the numbers of moles. Number of moles of what? Of sodium hydroxide. This is sodium hydroxide. Okay, number of moles. Why on earth do I do that? Because if you do that, that means the number of moles here is 0.014 moles. Then you can use the ratio to find out what is the number of moles of the acid. So the ratio is 1:2, right? So if this is 0.014, what do you think is the value of 1? What times 2 equal to 0.04? So in other words, the moles of H2 number of moles of H2SO4 is 0.014 divided by 2. Am I right? Divided by 2, which is 0.007. Okay, now you know the number of moles of acid reacted with the sodium hydroxide is 0.007. Very good. But is this your answer? No. Why no? Because they want the concentration. So again, because it is acid, is alkaline, right? The formula that I introduced to you whenever you see this is to use the one that I box up, right? The one in the star. So what is the answer? So now I know the acid is 0.007, right? And I want to find the concentration of the acid. Now I'm talking about acid, I'm not talking about sodium hydroxide anymore. Then I multiply by the volume that I use. So what is the volume of acid that's used? What is the volume of the acid that's used? Not the volume of the sodium hydroxide, isn't it 25? Remember to change it to the MQ. And if you solve this, I think the answer is A. Okay, take some time to revise this question again. Play back the video if you need to. Number 8. When sulfuric acid dissolves in water, there is an increase in temperature. Okay, what does that mean? This is when ammonium nitrate dissolves in water, there is a decrease in temperature. Again, what does that mean? Right. Step number 1 is to look at the data given, the information given. Step number 2 is to find out what are the hidden message, what are the hidden data. Okay, so the hidden data from here is simply says exothermic, isn't it? Because there's a increase in temperature. This one is endothermic, because there's a decrease in temperature. Oh, so I just told you the answer, right? So this cannot be correct. I just say it's endothermic. Okay, this one they never tell you. Let me see. Okay, so when ammonium nitrate dissolves in water, the particles in ammonium nitrate, the particles in gain energy. I think this is correct. Right? And when sulfuric acid dissolves in water, gain in energy. No, I know what you're thinking. I thought you say that when ammonium nitrate dissolves in water, right, the particles gain energy. Am I right or wrong? If it is gain energy, how come there's a decrease in temperature? How come like that? This is a typical mistake done by the student again and again and again. So the particles I just draw like that, okay? Ammonium nitrate. Let's say these are the particles. So as they dissolve in water, and you put your thermometer inside, okay, let's say inside this solution. Ask yourself, what is the thermometer measuring? Is it measuring that particular particle? I use green color. I don't think you agree with Mr. Louis. Are you measuring the temperature of that tiny little particle, or are you measuring the temperature of the surroundings of the particles? Surrounding the white space or the particle itself? And I think you get it now. Because the ammonium nitrate gain energy, it means it absorb in. It absorb all the, let me see, let me do it another time. So imagine this is your particle, okay? I exaggerated. If we absorb all the energy in, yes, this particle gain in energy, resulting the green part here, to have lower lower temperature, because uh, it absorb all the energy in, right? Therefore, your thermometer is measuring the temperature here, right, outside here, not touching the this ammonium ion. This is impossible, right, because ion is so small. So the same thing I use as the classroom. So imagine you are the particle, and you want to measure the temperature of the room, your classroom, right? The thermometer is not measuring your temperature, which is 36.9 or 37 degrees Celsius. It's actually measuring the air temperature in your classroom. but your temperature is very hot, I mean 37, but the room temperature cannot be 37, maybe 32, maybe 31, depending on the weather. Okay, again, I think this topic you need to sit down and think, and you can get it one day. Okay, quickly, number 9, two test tube. Again, I saw this phrase, right? So whenever you see this, why don't you just take a good practice? So number of moles of acid, in this case HCl, will be equal to concentration, which is 2 times the volume. So you have, okay, just practice like that. Take 2, which is the concentration, multiplied by 15, the volume. Okay, this is the number of moles of HCl present in the liquid. Present in the liquid. Okay, never mind. This is not a calculation, so I just practice. The complete reaction in tube P takes 100 seconds, and this one 40 seconds. So which one is faster? Q is faster, right? I mean, very obvious. So what causes Q to be faster? Both the concentration of the acid is the same. I assume the temperature is the same. They never say you warm up P and Q. The only difference is that, this is 0.5 gram and 0.5 gram of roll. Roll means roll up, right? And this one exposed. I guess this means like that. This one is roll up. When you roll up the magnesium, don't you think there's less surface area for the particles of the HCl hydrogen ions to get in contact with the surface area? Yep. So if there's less surface area of contact, of course the reaction will be slower lah. Okay, so let's cancel out the obvious. There are fewer particles of HCl, which is wrong because both of them have the same number of moles. Both of them is 2 times 15 upon 1000, right? There are fewer particles of magnesium. Oh, there are fewer particles, but then this is both of them are 0.5, right? 0.5. Are there fewer particles of magnesium exposed? You may think so, but let us see where is there another better answer. The acid chloride, I don't think so because at temperature is the same. I'm left with number 1. The acid particles collided with magnesium particles more frequently. Yeah, this answer and this answer, I think A is a better answer, right? This is what we call the collision theory of the rate of reaction, about colliding, not about numbers. Actually, we wouldn't know, right? Maybe they just say roll, but maybe it's uh, you know same amount of surface area being exposed in this case. Number 10, chlorine react with iron chloride. Okay, this is a typical redox, and everyone do not like. So as I say again, what's given to you is over here. I always write this down first. Okay, Raymond and Gina Ong love history and love English, means oxidize. Why don't I write down the opposite of it? You must practice writing down what we call things to memorize. The more you write it down, the better you will be and get less. You will get more correct answers. Which statement about the reaction is correct? Oh dear. So is the oxidizing agent oxidize? Oxidizing agent opposite, right? So if you are oxidizing agent, you are reduced. Okay, not oxidized. So this one cannot be true, right? The this one is wrong. I cannot say reducing agent is reduced. Reducing agent is oxidized. Oxidizing agent is reduced. Okay. Okay. Spend some time getting this. Okay, we're left with B and C. The iron chloride is an oxidizing agent is reduced. or you say that iron 2 chloride is a reducing agent. Okay, let us see first. Which one is the iron 2? This is iron 2 because, right, as I said in the previous question, let us think about how did it come about. So if you push the charges back, so you can see 2 plus and Cl minus, right? So these are the ions. So this is iron 2 chloride. Iron 2 chloride. Okay? This means iron 2 chloride. Okay, so they are talking about this thing here. Okay. So is it an oxidizing agent? Or is it a reducing agent? Because if it's a reducing agent, then it's oxidized, which is correct. If iron 2 oxidizing, then it's reduced. This is also correct. Okay, so let's see. So you see FeCl2, and what is the product? You only have one product, and if I use the same method, I realize that this is Fe3 plus and this is Fe2 plus. So in other words, during this reaction, the Fe2 plus has become Fe3 plus. Right? We say that the oxidation state of iron has gone from positive 2 to positive 3. So there was a gain in oxidation state. GO stands for gain in oxygen as well as gain in oxidation state. So 2 plus to 3 plus is an increase. If I draw a number line for you, okay, I draw a number line for you. Put 0 here, right? So 1, 2, 3, negative 1, negative 2, negative 3. Okay, let's draw a number line. So if you go from positive 2 to positive 3, you increase in oxidation state. If you move from this direction, we say decrease in oxidation state. Decrease because getting lower and lower. Okay, so what happens is an increase in oxidation state. That means that substance is Ra. That substance is oxidized. So iron 2 chloride is a reducing agent and is oxidized. Okay, if you need to take some time to understand, you still don't understand, can look for your teachers, any teachers. Number 11, which statements about oxides are correct? Okay, this is acid, bases, and salt. Let's see. An aqueous solution of sulfur dioxide has a pH of less than 7. Well, that means acid, right? Yes, of course. Sulfur dioxide is a non-metal oxide, and all non-metal oxides, some of them, not all of them, are acidic oxide. Okay, revise. You can look at acid, bases, and salt. Okay, let me see whether I have it here. Yes, maybe I have it. Yeah, okay. So you can see there are a few types of oxides, right? Basic oxides and amphoteric oxides. Basic oxides are metal oxides, right? That means copper, oxygen, combined sodium and oxygen. There are only 3 very special oxides. They are metal oxide, but they are called amphoteric oxides. Okay, you can take a look at this piece of notes again. And non-metal elements are always acidic oxide or neutral oxide. So how do you memorize it? Actually, if you think about it, it's very simple. If it's a non-metal oxide, that means it is an acidic oxide, unless it is this 3. I call it no cold water. Okay, carbon monoxide, nitrogen oxide, or water. They are neutral oxide. That means they won't react with acid or alkali to give you salt. Acidic oxide are the rest of the non-metal oxides. Okay, similarly, the amphoteric oxides are metallic oxides. So how do you differentiate between this basic and the amphoteric? Again, you do the simple one. You only memorize this. Zinc, aluminium, and lead oxide are amphoteric oxide. The rest are all basic oxide. Okay, the metal oxides, the basic oxide. And if you ask me what does amphoteric oxide means, it simply means as the word ampho means by, two. So that means it will react with acid to form salt and water. It also react with alkalis to give you salt and water. This is a complex salt. Okay, it's just a salt, so you you don't they won't ask you how to write this. Just they will just ask you to understand what's amphoteric oxide. The three examples. Okay, so revise. Okay, let me see. How about this? An aqueous solution of this is correct. An aqueous solution of potassium oxide turns blue litmus paper red. Now, potassium oxide, if you can, require remember what I said just now. It was metal oxide, right? So it forms if you dissolve in water, it gives you an alkali. KOH. It's an alkali. Alkali does not turn blue to red. Blue remains blue, turns red to blue. Carbon dioxide react with sulfuric acid to make a salt again. This requires you to go back to this page. Okay, so if you look at this, carbon dioxide, which is of course an acidic oxide. If you look at acidic oxide, carbon dioxide, okay, because it is a non-metal element combining with oxygen, okay, to give you oxide. So acidic oxide. Acidic oxide will not react with acid to give a salt. Always remember what I mentioned in class, opposites attracts. So an acid must react with a base, which is the opposite of an acid, the nature, the characteristics. So therefore, acid and base will give you salt and water. Acidic oxide will not give you any salt, any water. Similarly, a basic oxide will not react with a base, an alkali in this case, to give you a salt and water. Same, if the same, you will not have any product. Same nature. Okay. So potassium oxide reacts. I think yes, because potassium oxide is a basic oxide, non-metal basic oxide, and of course, as I mentioned just now, it will give you red water, give you KOH, and this is the product, right? It's salt and water. So these two are opposites, so therefore this is correct. So 1 and 4. Okay, I need to go a bit faster. Number 12. Okay, this is no longer in the syllabus, but I just mentioned briefly. Okay, so this is a sodium salt. Can you remember what I said in earlier? Sodium salt are colorless. Sodium salts are soluble in water. So for sodium, potassium, and ammonium salts, okay, they are all prepared by the titration method. Okay, sodium, this one, right? Can you remember this one? Okay, okay, this is atomic structure. Element R has 12 protons. Q has 8 more protons. This is tricky. Okay, let's do it. So these are given to you, right? So you must, step 1 is to look at all the data you are given, and then step 2 is to look at the hidden information. So 12 protons. So 12 protons. You need to write this down. Okay, the electronic configuration. Very good. Q has 8 more protons. 8 more protons. So 8 more protons. Is this the meaning of 8 more protons? Uh, 8 more protons. Are you sure? Okay, take a look at. Originally it's 282. If you think that Q is 288 is 8 more protons, you are wrong, because 288 means 6 more protons, not 8 more protons. So 2 plus 6 is equal to 8, isn't it? So you have to add another 2 more, right? Okay, you think about it. Okay, 288 means 6 more protons, not 8 more protons. 2882 means 8 more protons. Okay, you think about it. Okay, 8 more. Huh? Okay, so if like that, can I say Q has more electron shells than R? Yeah, it's 3 and it's 4. I think this is quite correct. It has more electrons in outermost shell. See, the outermost shell 2, 2, right? So no. Q is a different group of periodic table from R. So because the outermost is 2 and 2, so it is the same periodic group. Q is the same period. So this is R is 2882, so it's period 3, and Q 282 is in period 4. So A is answer. Okay. 14 is a group 17 question, right? Can you remember? So fluorine, chlorine, bromine, and iodine. Which one is more reactive, the most reactive? Which one? Okay, look at your textbook, and this one is the most powerful one. Opposites of the group 1. Huh? Okay, and the most powerful one is F2. And the most reactive halogen can displace the halogen of the halide solution. Okay, so let's get something. Bromine is a red brown gas. It's a liquid, it's not a gas. Iodine is a gray solid. Okay. Iodine is a purple vapor. Yes, iodine is very unique. When a solid form, it's a gray solid. When it sublimes or you warm it up a bit, it becomes have a purple vapor. Okay, purple vapor. And then of course, if you dissolve in alcohol, or you get a brown solution. If it's in water, slightly soluble, it will be a brown solution also. Okay, so it could be B, C, or D, but there's something more to it. Bromine is a red-brown liquid, so I put bromine, that reacts with potassium iodide. How about C? Iodine is a gray solid that reacts with potassium bromide. And iodine is a purple vapor that's sodium chloride. Okay, I have written down this, so let us see whether which one is correct or wrong. And straight away I saw something wrong. Why? Because a more reactive element can displace a less reactive element, right? So I highlight this one and I highlight this one. Is bromine more reactive than iodide? Yes, right? So this can occur, B can occur. Is iodine more reactive than bromine? In this case, the halogen. No, because iodine is below, right? Is iodine more reactive than the chlorine in chlorine? No. So you must do this first, okay? So since this is not reactive, that means there's no reaction. No reaction. Only the more reactive can displace. And if it can displace, then what is happening? So I see, so K, right now K, this fellow kick the iodine out. So K become Br, right? And iodine kick out become I. Now I is an atom, they need to form I2 because uh, iodine 7 valence electron, you need to have 2 atoms to form a more stable molecule, so that's why it's called I2. Same thing with bromine. So bromine atom cannot exist, it needs to combine with another bromine atom to give you a bromine molecule to be stable. That's why you can see in the lab, that's why you can see you can use it. If it's not stable, then it wouldn't exist, or exists in only a fraction of a second, and then it had to uh, uncombine again. Okay, become ions whatsoever. Okay, this is basic chemistry. Basic chemistry. Okay, so you may say something is wrong. How come Br2? Okay, then you never balance it. Okay, that's all. You balance it, and yep, it looks nice like that. Okay, so B is the answer. So I revised a lot of concept over here. So that's why this paper takes a bit a longer time. Okay, W X Y. Okay, this is metal reactivity series. Quite straightforward. Okay, so let's do something. Does not react with acid at all. I think if acid cannot even react with the metal, is highly unreactive. Okay, and then reacts with cold water. So this is very reactive. Okay, if you look at W and Z, I write it down. So sorry, X and Z, not W and Z. X and steam, right? X for steam, huh? Any reaction, yes. X with water, which is cold water. I just put cold, C for cold. No react, no reaction, right? X with cold, no reaction. How about Z? Z reacts with steam or not? No, right? Not with steam. Z reacts slowly with acid, or not water, acid, huh? Slowly, okay, slowly. Okay, that means cold acid, not hot acid. Okay, so which one is the most reactive? So I put W here first because it is the okay. So Y is more reactive than X, or Y is more reactive than Z. Let me see. So you compare X and Z. Which one is more reactive metal? Which one is a more reactive metal? X or Z? So I can see that for X, it will react with cold water, but Z don't even react with cold water. So I can deduce that X is more reactive than Z. So I come to this little deduction. So I look at the information. I need step number 2. I need to find out the hidden information. Hidden information. So do you agree with what I said? Y is very reactive, the most reactive. W is the least reactive. So that's why I put the Y and the W first. Then I got to decide whether X is more reactive than Z or Z is more reactive than X. So based on what I have written on top here, I can deduce that X is more reactive than Z. Why? Because X will react with cold water, Z don't even react with cold water. And then X will not react with cold water, then Z only react with HCl. That means Z won't react with cold water but only react with HCl. Okay, that's a hidden meaning. Okay, so I get this. Take your time to see whether you can come up with this deduction. But this question is tricky because they ask you easily, abstract, and most difficult. If this is very reactive, what does that mean? You can think of it in this way. If it's very reactive, means the metal has combined strongly to the oxide, the or carbonates or whatsoever with of another element. Because it's very reactive. So very reactive means very sticky. How about that? Not reactive, not sticky. Okay, not sticky. So if you want to extract it, the more sticky it is, the more reactive it is, more difficult to be extracted. The less sticky it is, the easier to extract, right? That's if a tape is less sticky to the wall, you easily pull it off. The one that's very sticky to the wall, uh, very difficult to pull it off. Very difficult to extract. So I think most of the students will get it wrong. Answer is B, right? Opposite of reactivity. Okay. Based on this, the same, this is also under extraction, right? From the ores by carbon. Okay, this one, if you study, it should be here. Let me see whether I can find the notes. Yeah, okay, I think I can find it. Okay, so right, this is the very famous please stop calling me a crazy zebra in Tamil language, right? And so on and so forth. So can you see this method relativity series? Okay, iron, and so if you can remember this, you can basically know how to answer that question. So carbon, where's carbon? Okay, carbon is here. So carbon cannot extract, okay, cannot extract any potassium oxide, calcium oxide, cannot separate the metal from the oxides. Remember, metal oxides is found in the ore. So this is a rock and sodium oxide, okay, or calcium oxide whatsoever. You need to get rid of the O from the metal. Get rid. If you don't get rid of the oxygen, then how are you going to take out the metal? Okay, please take note of that. So from here, I think copper can be extracted by carbon and hydrogen. Oh, can can you see this part here? No reaction when heated with hydrogen gas. In other words, for no reaction, can you see? Zinc, zinc got any reaction? No reaction. How about lead? Lead has reaction. So if that's the case, copper, zinc, this one has no reaction, right? That, what does that mean? That means when you use zinc oxide, you react with hydrogen gas, no no reaction, no extraction. I mean nothing. You cannot pull the zinc from away from the zinc oxide. Then what does this mean? So let's say this is the lead oxide concern. That means this can occur. Okay, maybe Pb2O3 or whatsoever, it doesn't matter. Okay, so C. This answer is no longer in the syllabus, but I can just do this is the fuel, right? You can just get it from your textbook. Okay, 18. Alright, alkanes. General formula, correct. Because they are unsaturated alkanes, no. Unsaturated means C to C double bond, right? So 2 is wrong. We're left with 1 and 4. I have to decide 1 and 4. The viscosity decreases as the number of, oh, I think number 1 is wrong, and the fluidity, then this is correct. Why is number 1 wrong? Viscosity means the rate of flow. So for example, oil has a higher viscosity than water. Okay, so gases always have a low viscosity because you can see gas can flow so easily, right? Um, so as you go down, the number of carbon atoms increase. So let's say carbon, right? So many carbons, right? If you have a long chain of carbon, right? So there is, can I erase? I can't erase this. See, you have more intermolecular forces of attraction. If you have more intermolecular attraction, the flow will it decrease or increase? Is it easier to move the molecules around? By the way, this is C. This is C, not, you think it's a molecule. Sorry, why don't I draw over here? C, 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 C. C. Okay, so if you have a very long chain, okay, the carbon increases, the intermolecular forces of attraction increases, right? And therefore the viscosity increase because it's more difficult for the molecules to slide against each other, right? To slide because there's so many bonds. If you have only shorter bond, then it's easier for you to flow. I mean, for the molecules to slide against each other. Okay, so the answers is 3 and 4 because 4 is correct. The flammability decreases. Then what does this mean? Flammability decreases. That simply means more difficult to burn. More difficult to burn. Combust, right? You burn combustion. So, which is correct lah. It's easier for you to burn ethane or methane than to burn propane, the 5 carbon. Easier to burn. So when it's easier to burn, we say the flammability uh, increase. If we say it's more difficult to burn, we say the flammability decrease. But why you ask me how come it decreases? Because you can see as there's more carbon, you need to let me use the color. You need to separate all the carbon. How many times? Why you need to separate? Because when you burn something, what do you get? Carbon dioxide and water, ma. In order to get carbon dioxide and water, this carbon got to be separated first. Then you combine oxygen to give you carbon dioxide and then of course water. Okay, so flammability will decrease if the number of carbon atoms increases. It is the same for the alkenes. It's the same for the alcohols. Okay, so it's more difficult to burn, say, butanol compared to methanol or ethanol. Ethanol is very flammable. Ethanol is very flammable. That means it is the flammability increases. It's very easily burnt. Number 19, which statement about an alcohol is correct? So this one learn by heart. Alcohol doesn't decolorize. Alcohol only alkene. Please remember that. Will it acidify? Will it turn acidified? Alcohol. Alcohol. Alcohol turns acid. No, right? Acidified potassium manganate is always purple, so it didn't turn it purple. If you if you say that potassium permanganate reacts with an alcohol, then yes, it does. It will give you a carboxylic acid, and if that carboxylic acid is given, then actually it's colorless, not purple. Okay, it will turn colorless. It undergoes addition. No, addition is only with alkenes. And how about, oh yes, this is the slow reaction. Yes, oxidize. So oxygen in air by bacteria, right? So the bacteria can change any alcohol to the carboxylic acid. Okay, so this one we revise carboxylic acid and alcohol is there. And lastly, it's a giveaway. It's a giveaway question. What is the most abundant noble gas? Is argon. Nothing else, huh? Not xenon, not helium whatsoever. Okay, this took a bit longer time. That's yep. Thanks for watching.